welcome to my bench. In my normal mode of let's put something on the internet that's never been there before, at least on YouTube, today we've got the Fisher transistor preamplifier and equalizer model TR-1. Fisher Radio Corporation in New York. Serial number 10458-B. This is a little mic preamp or phono preamp. Here we go. It's even got the tag on it, the Fisher transistor preamplifier and equalizer, on-off volume control. And on the back we've got a switch for phono and mic, a switch for high and low level. Okay, we'll figure out what all this stuff is for. We have an output here. We have input 1 and input 2. Nice. And we got this thing hanging out the side. I don't know anything about this. I took the screws out and that was about it. So we're going to find out together. Alright? Well, let's open it up. Okay. That's the bottom. Wow. Interesting. I believe those are going to be transistor connectors. Socketed, I believe. Maybe. Not much in this little bubby. But let's take a look and see. How's the top? Oh, it's just on with little tabs. Alright. Oh man, look at this. Look at this. Come on. Focus. Focus, focus, focus. Not so much. There we go. Yep. The transistors are in sockets. Look at that. Cool. It is an RCA 2N109. Wow. In the socket. And there's 3 of them. Alright, I did manage to find a manual. So let's see if we can get the manual up here. Any luck at all? Yep. Alright, there it is. Spread it out some. Okay, not much. I mean, the manual is kind of fuzzy, but that's the best I could do. Whew, alright. Well, there's some caps in here, and we're going to have to check them first. This thing is from 1958. Believe it or not. So, before we do anything to it, I want to check this cap. 15 working volts, 100 microfarads, and these 2 right there. So, let us, I mean, that one, that would be this cap right here. So, that, it's right off the power supply. So let's check that one first, because I have had these guys go bad because they thought it would be a good idea. This is an old solder. Point. Alright. Well, bring this meter into it here. Alright. This thing tested bad. It's shorted. But let's give a test to one of these guys here. Plus end here. And negative end here. And see what it says. You can't see that, can you? Too much light. And that didn't help. Alright. In the way. 2 2.76 nanofarads. Yeah, that's supposed to be 100 microfarads at 3 volts. We'll just test this one in circuit, see if it comes out the same thing. In circuit, this thing is not very good. Yeah, no, it's not. I'm just going to say it's bad. And I pulled the end of this one. Let's see what this is. This is supposed to be 15 microfarad cap. 12 volts. And it is reading 58 nanofarads, 16.14K. Yeah, it's a resistor, and it's factor, power factor 30, not power factor. It's supposed to be 90 or close to. All right, so all the caps are bad, but let's try out these transistors here and see what they say. So I don't know what the pinout is on these, but I know they're PNPs because minus voltages all over the place. So go here, probably base in the middle, and collect, or probably, I don't know, we'll find out. And on. This thing isn't the greatest tester in the world, but it does tell you what they are. Okay, so it is a PNP, 93 HFE forward 124 millivolts. So it's not a silicon, that's for sure. And it is collector base emitter. So collector base emitter. Yep. Collector base emitter. So that one's good. That's good because I'm pretty darn sure I haven't got any 2N102s. Let's try this one. And see what it says. A BJ of HFE of 120, 132 millivolts. Same thing, but it's good. All right. Put you back in. And pull this one out and give it a try. And see what it says. Collector, base, emitter. See what this one says. And it says, yep, it's good. HFE of 95 and 138 millivolts. Alright, so all the transistors are good. I'm going to say all the capacitors are bad. And just for fun, we tested this on there, and it tested kind of lousy. So let's see, 1 and 3. Let's see what it says for this capacitor. Takes it a second on 100 microfarads. 1.5 ohms at 137 microfarads. Whichever, it is definitely out of tolerance. Alright, so capacitors are all bad. Transistors are good. So I gotta change all that stuff. So I'll be back when that happens. Okay, we're back. And here's my pile of capacitors. And just for fun, let's check these things and see what they say. There was 1s, 15s, which I replaced with 10s because I didn't have any 15s, and 100s. So yeah, that's all of those. All right, so let's Let's check and see. Here's a 1 microfarad. Nashville cap, 1 microfarad, 25 volts. And the red end on these, if you ever see these, they've got, well, they got two ends. The little bulgy red end here, if you can see it, that's plus. That's the plus end. So I had to figure that out by looking at the schematic. So let's clamp this on here. We're at 100 hertz. And this is supposed to be 1 microfarad. It is 98 picofarads. Yeah. Let's try another one. Yeah, here's a good one. This will show you. See the one red end there is bulgy, and the other end isn't? Well, the red end is plus. The other one was pretty iffy at best as far as looking at it. What's this one say? 168 picofarads. It doesn't even recognize it as a capacitor. Alright, here's one of my 15s. Plus end on these is marked. We're at 100 hertz on these because that's what this thing works at. 1,000 picofarads. Okay. That one's not working. Be nice if I could get one that even came out close. 1,000 picofarads at 72. This can't be right. Let me get a cap. I can't believe that they're all that bad. I mean, that's really bad. Let's find one. Here's a 10 at 50. See if there's something wrong with my meter here. I don't think so. Alright, so what's this reading? 9.48, 6.4 ohms, and minus 87 on a Q factor. So yeah, the meter's fine. These capacitors are that bad. Here's another one. This one is 100 at 3 volts. And it is reading 2 nanofarads. Just all over the place. Here's another one, 100 microfarads. It is reading 2 nanofarads minus 82. And I don't know what. Okay. And here's the last of the 15s. $1,400 picofarads. Okay, so that just proves beyond any shadow of a doubt every cap in it was bad. Here's our 100 microfarad that we had in here. Yeah, 130 microfarads, 81 Q, and 1.79 ohms. That's this thing here. So, yeah, it's beyond any shadow of a doubt every cap in it was bad. So we got it hooked up. The output I've got going to my little amplifier over here. The input I've got coming from my little sine wave generator at 1 kilohertz. I did not check all the resistors or these capacitors, but they don't generally go bad that much. But anyway, so let's see. What am I feeding? 1.7 volts sine wave at 1 kilohertz. So let's turn it on. Oh, we got audio and a dirty pot. Well, you know, in 1958, 58 guys, I mean, come on. Alright, so we got, let's see, we got, there's phono input and there's mic input. Nah. I'm on input 1. Let's try input 2, if I can get to it. Okay. So input 2. Okay, so, alright. So, I got, bring this back out a little bit. Alright, so, input 2 is louder than input 1. I haven't looked at this quite a bit. Okay. Oh, alright. Alright, so, input 1, if you listen right there, I am on high-level output, low-level output. Mic input and phono input doesn't make a lot of difference, at least the way we're testing it. But if we go to input 1 or 2 down here, it's full all the time, and there's no change on input mic or, okay. So, let's figure out why that is, or if that's supposed to be that way. Let's bring the manual back up. Alright, and turn the meter off because it's in the way. Alright, so, basically, input 2, let's see, input 1 goes through a 10K, looks like a 10K resistor. I can't really read it. Through the capacitor into this transistor. Maybe that's 22K. And that capacitor was dead shot. And input 2 just goes straight through. Alright, so input 2 goes straight through and it's fine. There's 2200 ohms. So high is open. Low is closed. So input 1 is going to form... Okay, so there's a voltage divider between this, whatever K that is, and this 2200 for input 1. Input 2 doesn't have a voltage divider, it just goes right straight in. Okay, I got it. I see. Alright, so here we go. Here's our input. Input 2 goes right through the cap and into it, with a 2200 ohm to ground. Now, you can cut that 2200 ohm in or out. It's not going to make a lot of difference. However, input 1 has, I don't know what K that is. I can't quite read it. And it's forming a voltage divider when you put it in high, I think. Yeah, in high it's open, in low it's closed, according to this here. So... that's going to give you control over input 1, but not over input 2. Alright, so we got our transistor, another cap that was completely open, going into this transistor, which is good. Alright, so everything is working the way it's supposed to be working, at least it appears to be. So now what we, okay, phono and mic. Phono... what is it? It's in mic position. Alright, so it puts in some filtering for the mic. A low pass filter here, I believe. It's shown in phono position. Alright, so in phono position it puts 3800 picofarad, I guess, in a 22K resistor as a low pass filter here. And another filter on the output. So our what we're doing with this 1K is not going to make a heck of a lot of difference to it. So that's okay. All right, now what we want to test. Let's get rid of this. So we know our output works. So we need to get an output over here to Let's see, where's my output is right here. And ground. And we're going to put that into the first of all, we're going to open this up a little bit. I really don't like these. I got to get better banana plugs, because these just lose their elasticity, I guess you'd call it. It's metal, I know that, but I mean, whatever. And they won't stay in the hole. Alright, so let's see. We want to find out how good this thing is. Set level. Ooh, okay. Let's do this on... I'm on 2. Too much stuff on the bench. I'm trying a new microphone, see if I like it. I don't know if I like it or not. But it's not mounted correctly, it's just sitting on the bench. Alright, let's try that again. Ground over to the distortion analyzer. Let's give it a little more input. Okay. And we'll turn it down. You can't see this, but I'll tell you what's going on. Alright. So I know that the output of this little function generator is good down to as low as I can read, which is about 0.1% distortion. And so what I want to measure here is how good is this thing at 1 kilohertz. And the answer is tweaking up here about I'm on 1, so about 0.5, approximately 0.5. So let's try it on the other input. That means I've got to recenter this thing. Wow. Okay. And on input number 1, it's the same. It's 0.5. So distortion's about 0.5. We take this output here, plug it back in. I unplugged it because I didn't want to get all that distortion. There we go. Well, cool. All right, so it's not the cleanest thing in the world, but it's also from 1958. Basically, it's a 3-transistor amplifier. Let's take a look at the manual again, just real quick. It's 3-transistor amplifier. So we've got our input. This amp is a first AF amp. Runs wide open all the time. Where's your volume control? Volume control. Okay, yeah, I know it's on the switch, but where's it at on the schematic? Okay, alright, so right here is your volume control. So these two guys are full on running all the time, and depending on what kind of filtering you put into them, for low pass filter, for phono or microphone, and then your volume control is here, and your final output, third AF transistor is here, and there's your output. So basically it appears to work. Cool. I'm thinking about getting a turntable. Well, I want to get a turntable, and I want to see if this thing would be good enough to use on that turntable. I can't tell 0.5% distortion personally, so I'm not worried about that. Cool. Yeah, So I got to find me a halfway decent somewhere turntable just for the fun of it. Only got a couple of records. And see if this thing will work with it. Hey, another piece of equipment from the long gone past that nobody's ever bothered to put on the net. For pretty much good reasons, I guess. Antique, but we got to see these really old transistors. We got to see just how bad capacitors can actually be. Just for fun, I want to take this thing and I want to check one of these guys because it's supposed to be 1 microfarad. This is just a plain old meter. Yeah. 80 picofarad. Yep. So, the big fancy meter wasn't lying. They are worthless. They are shot. Anyhow, hey, thanks for watching. And don't forget to subscribe and ring that bell so you know when I'm doing more maybe old stuff. And don't forget to comment. If you like this stuff, give it a thumbs up. Hey, see you next time.